Welcome viewers, in this video we will see the method of drawing the dual of a network. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. What is the method to draw the dual of a network? We know that original network, from that we can draw the dual network, duality. The following steps are followed to draw the dual of a given electrical network. The first one is a dot is placed in each independent loop of the original network. These dots placed inside the loop corresponding to the independent nodes in the dual network. So the first step is we need to identify what are the loops available. For every loop we need to place the dot inside the circuit. We need to place the dot for every individual loop. That is very similar to the node in the dual network, right? So the next step, second step, is a dot is placed outside the given network. This corresponds to the reference node of the dual network. So for every loop we place the dot inside the network. One dot is placed outside the network, that is called a reference node of the dual network. All the dots are connected by the dotted lines crossing all the branches. Now we need to connect all the dots. That is by the dotted line that is going through the branches. That is either resistor, capacitor, or voltage sources. Right? So the dots are connected by the dotted line through the branches, through the elements. The dotted lines should cross only one branch at a time. So for example, if the resistor and voltage source available means we need to draw separate line for voltage source, separate line for resistor. Only one element should cross. The dual elements will form the branches connecting the corresponding nodes in the dual network, right? So the dual elements. So while crossing that, the resistor means the dual element, conductance should be there. Inductor means capacitor. Capacitor means inductor. Voltage source means current source. So the corresponding nodes in the dual network, that is given. So while connecting the dots through the element, we need to find the dual of the network. So that dotted line is nothing but a dual of a original network. We need to draw the dual network separately. So there are two nodes available. One is the voltage rise in the clockwise direction correspond to a current flowing towards the independent of the network. Right? The voltage rise in clockwise direction. A clockwise direction in the loop correspond to the positive polarity at the dual of independent node. So we need to see the polarity, whether it is rising polarity or falling polarity. Rising means the current will also going upward. The polarity is falling means the current will go downwards, right? So accordingly we need to identify. Now we'll see the example problem. So in this example problem, this is a given network is available. So the two voltage sources available, 5 voltage and 10 voltage, then 3 resistor, 3 ohm, 4 ohm and 7 ohm. So we have two loops available. We know that loop is nothing but a closed path. This is one loop. Is the current flowing through the first loop is I1. Similarly, this is another loop. The current flowing through the loop is I2. Right? So the first step, we need to identify how many loops are available. Now we can go to the dual network. You will follow the procedure given by the dual network. So this is the diagram is drawn again. The black color diagram is the original network. The first step is we need to place the dot in each and every loop. So this is first loop. We placed one dot and numbered as 1. This is another loop. Here one more dot is placed, numbered as 2. So we have two loops available. So two dots are placed, numbered as 1 and 2. And one dot is placed outside the loop. This is called a reference node. This is called reference node, right? So what is the next step? We need to connect all the dots, right? First we will connect the dot 1 and dot 2 through the resistor 7 ohm, right? Through the resistor 7 ohm on the dotted lines. The dot 1 and 2 is connected by the dot line through the 7 ohm resistor. Only in between 1 and 2 only 7 ohm resistor is available. So this 7 ohm resistor now will convert it into 7 conductance, right? So that is connected between 1 and 2, right? Now we'll see 1 and 0. What are the terms available connected between 1 and 0? So this voltage source is connected and also the resistor is connected. Two elements are connected between 0 and 1, right? So this is the element 0. So I already know that only in the dotted lines only one element should be there. If two elements are there, mean you have to draw the separate dotted lines, right? So this line connecting the node 1 and 0 through the voltage source. This line connecting the node 1 and 0 through the 3 ohm resistor. So 3 ohm resistor will be converted into 3 conductance that is connected between 1 and 2. Similarly, 5 voltage source is converted into 5 ampere current source, right? Rising polarity. What is the rising polarity? See the current direction. Current is flowing in clockwise direction. See this, it is going from negative terminal to positive terminal. So negative to positive means voltage rise, right? So the current is flowing like this. So like this means it is flowing from negative to positive, rise in polarity, right? Negative to positive, rise in polarity, so that the current source also 5 ampere rise in polarity, right? So between 1 and 0 voltage source is there, that is converted into current source. 3 ohm resistor, that is converted into 3 ohm 3 conductance, that is 1 and 2. Now we'll see 0, 2 and 0. What are the terms available between 2 and 0? So here also one more voltage source is available and one resistor available between the dot 2 and 0. So this line connecting the dot 2 to the dot 0 through the voltage source. This line connecting the dot 2 with the dot 0 with 4 ohm resistor. So this 4 ohm resistor will be converted into 4 mho conductance connected between 2 and 0. Now see the polarity of current. See the current is flowing, same thing. Current is flowing in clockwise direction but is flowing from positive terminal to negative terminal, right? Positive terminal to negative terminal. So the fall in current. So the voltage current source is going down, right? Connected between 2 and 0. So here current is rising negative to positive. Here current is flowing positive to negative, so that fall in potential, current also going in the downward direction, right? So see this 7 ohm converted into 7 mho conductance connected between 1 and 2. 3 ohm converted into 3 mho connected between 1 and 0. 4 ohm converted into 4 mho conductance connected between 2 and 0. This 5 voltage connected between 1 and 0 converted into 5 ampere current source with going upward direction. This 10 voltage source converted into 10 ampere current source going down because the current is flow from positive to negative. So based on that we'll see the dual network. So this is the dual network. Between 1 and 2 7 mho conductance is there. Between 1 and 0 this 3 mho conductance and also 5 ampere current source going rising current. Between 2 and 0 4 mho conductance and 10 ampere current source going down, right? So 1 and 2 this one resistor. Between 1 and 0 one resistor and current source. Between 2 and 0 one more resistor and the another current source. So this is the dual of the network, dual of the given network. Now we'll see the description. Description is available. What we did, the sentences are available, we'll see that. So the description is, inside the loop 1 and 2 of the given network, dots are placed and named as 1 and 2. Outside the loop, the dot is kept and named as 0. The dot named as 1 and 2 are joined by the dotted line through the 7 ohm resistor, so that it will be converted into 7 mho conductance. Dot 1 is joined to dot 0 through the dotted lines. One is crossing the 3 ohm resistor, another one crossing the 5 voltage source. another one is crossing the 5 voltage source. So that this 3 ohm is converted into 3 more conductance, 5 voltage source is converted into 5 ampere current source going in a rise upward direction, right? Another dot 2, another dot is dot 2 and 0. Dot 2 is joined to dot 0 through the dotted lines. One is through the 4 ohm resistor, another one through the 10 voltage source. So that this 4 ohm resistor is converted into 4 more conductance. 10 voltage source is converted into 10 ampere current source going down because of falling potential. The dots are placed on the paper. They are connected by the dual network to obtain the dual. Connect the dual elements to obtain the dual network. So the dots 1, 2, 0 is placed in a paper. Between 1 and 2, one resistor is connected. Between 1 and 0, resistor and one current source is connected. Between 2 and 0, another resistor and current source is connected. So that is given here. So the note is there. There is no change of numerical values. There is no change. Numerical values are same. 7 ohm is means 7 more conductance. Both are value same. 5 ampere. 5 voltage means current. 5 voltage source means the current source also 5 ampere. Same thing. Resistor become conductance. Source voltages become source currents. So in this video, we'll see how to draw the dual network. What is the procedure available? And we discussed one example problem. And for example problem, what is the description? That also we discussed the description also. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.